Hello everyone, welcome back to my channel. My name is Dave. In this video, we'll be looking at this integral, which is the integral of x to the fourth times the quantity 1 minus x to the fourth all over 1 plus x squared. This was actually asked as a question in the Indian Institute of Technology Joint Entrance Examination in 2010. The IITs are a system of very prestigious higher educational institutes which are located all across India. It's said that the acceptance rate for IIT is less than 2%. In any case, this is a very interesting integral because the result contains both an approximation for pi, which was known since the time of Archimedes, and pi itself. So let's look at the integral. It's relatively easy to evaluate this integral by using brute force, without having to resort to any special techniques of integration. To begin, we first have to expand the numerator. According to the binomial theorem, 1 minus x to the fourth is equal to 1 minus 4x plus 6x squared minus 4x cubed plus x to the fourth. This means that x to the fourth times the quantity 1 minus x to the fourth is equal to x to the eighth minus 4x to the seventh plus 6x squared minus 4x to the fifth plus x to the fourth. At this point, we can begin to carry out polynomial long division by dividing what we just got by 1 plus x squared. So now we have our polynomial long division. In order to get x to the eighth, we have to multiply x squared by x to the sixth. If we do this, we're going to get x to the eighth and x to the sixth. We're going to write those down, but for now, we're just going to drop down the negative 4x to the seventh and the negative 4x to the fifth. In order to get negative 4x to the seventh, we have to multiply by negative 4x to the fifth. These are going to cancel out, and now we can subtract 6x to the sixth minus x to the sixth and drop it down. We can do the same thing and drop down the x to the fourth, and we're going to continue down the line until we reach the end. If we do this, we're going to get x to the sixth minus 4x to the fifth plus 5x to the fourth minus 4x squared plus a fraction, which is 4x squared over x squared plus 1. 4x squared over x squared plus 1 can be simplified. If we do this, we're going to get 4 minus 4 over x squared plus 1. Putting this all together, we now have two integrals. We have the integral from 0 to 1 of x to the sixth minus 4x to the fifth plus 5x fourth minus 4x squared plus 4 dx minus 4 times the integral from 0 to 1 of 1 over x squared plus 1. The first integral is simply a polynomial, and we can use the power rule to integrate it. And the second integral can be looked up. This is a basic integral, and it turns out that this is going to be the arctangent or the inverse tangent of x. Now, all that we really have left to do is to evaluate these two integrals. As I said before, we're going to use the fact that we can use the power rule on the integral that's boxed in green, and we're going to get x to the seventh over 7 minus 2/3 x to the sixth plus x to the fifth minus 4x cubed over 3 plus 4x evaluated at x equals 1. On the second integral, which is boxed in blue, we're going to use the fact that the integral of 1 over x squared plus 1 is simply the arctangent of x. Again, that's going to be evaluated at 1. Note that we don't actually have to evaluate it at 0 because plugging in 0 to either of these expressions is simply going to give us 0. So plugging in 1 gives us 1/7 minus 2/3 plus 1 minus 4/3 plus 4 minus pi. And if we remember that the original integral was the integral of x to the fourth times the quantity of 1 minus x to the fourth over 1 plus x squared taken from 0 to 1, this means that our answer is 22/7 minus pi. Now recall that the original question was actually to prove that 22 over 7 was greater than pi. This is a very simple argument, in fact, because this function is positive for all numbers on the interval on which we are integrating, and hence the integral must be greater than 0. Also, if we pick any number from 0 to 1 and plug it into the function, we'll get a positive number, which must mean that the integral is greater than 0. So that means that 22 over 7 minus pi is a positive number. and therefore 22 over 7 must therefore be necessarily greater than pi. And with that, we come to the end of the video. If you liked this video and found it useful, please like and subscribe and share with your friends. Thank you very much, and I'll see you in the next video.